Hello, today I'm going over the review in test 4 that's in my math lab, and on my screen are the test 4 notes which have the formulas that you will need, and you can have these out on your desktop while you are taking the test. So I'm going to go into the first problem here, and it says an ice cream store sells 2 drinks in 3 sizes and 5 flavors. How many ways can a customer order a drink? And we're going to use the first formula here, which is the fundamental counting principle. The number of ways in which a series of successive events can occur is found by multiplying the number of ways in which each thing can occur. So the number of ways to order a drink would be 2 times 3 times 5. And so we could just punch that on our calculator and get that answer. Okay, so that's just multiplying the numbers. A restaurant offers the following limited lunch menu. A main course has turkey, spaghetti, meatloaf, shrimp, and hamburger. The vegetables are peas, squash, cauliflower, eggplant. Choice of beverages are coffee, tea, milk, soda, and shakes. And the dessert choices are cake, pie, and sherbet. If one item is selected from each of the 4 groups, how many ways can a meal be ordered? So we need to see how many main courses we have, and that number is 5. We're going to multiply it by the number of vegetables we have, which is 4. We're going to multiply by the beverages of choice, 1, 2, 3, 4, 5, and then a dessert, so that's 3. So we're going to multiply 5 times 4 times 5 times 3. And that'll give you your total number of ways in which you can order a meal. The next problem, number 3. A person can order a new car with a choice of 5 possible colors, with or without AC, with or without automatic transmission, with or without power windows, and with or without CD player. How many different ways can a new car be ordered with regard to the options? So let's see how many different choices we have. I'm going to go to my screen here. All right, so we have 5 different colors, and then we have a choice of AC or no AC. So AC, there are 2 choices there, on or off, or with or without. And then we have automatic transmission. I'll call that AT. So we have 2 choices there. With or without power windows, we have 2 choices. With or without a CD player, we have 2 choices there. So how many different ways can we get a car with the options? Is 5 times 2 times 2 times 2 times 2, or we can punch out 5 times 2 to the 4th power on our calculator. And so we do that by multiplying 5 times 2 to the hat raised to the 4th power, and we have 80. So there's 80 possible combinations of ordering a car with these options. All right, so we're going to continue with using the fundamental counting principle in this problem as well. License plate in a particular state displays 2 letters followed by 5 numbers. How many different license plates can be manufactured for the state? All right, so we have 2 letters. I'm going to put 2 spaces here. And then we are followed by 5 numbers. 1, 2, 3, 4, 5. All right. So with a license plate with 7 characters, where you have 2 are letters and 5 are numbers, right? There are 26 letters in the alphabet that we can choose from for the first digit, and 26 letters we could choose from for the second one. And the next one is a number, and the number choices are 0 through 9, because these are single digits here. All right, so we have 10 numbers that are possible here, and so forth. So the total number of license plates that can be made in this state is 26 times 26, which we can do as 26 squared, times 10 raised to the 5th power. So 26, we could just hit the squared key, times 10 raised to the 5th power. And that is a big number there. 676 with 5 zeros there. So we have 67,600,000 different license plates that we can order for this state. I typed that in wrong. Okay, the next question, number 5. A stock can go up, go down, or stay unchanged. How many possibilities are there if you own 9 stocks? All right, so with the 9 stocks, I'm going to put 9 spaces here. And there are 3 different ways that stock can perform. It can either go up, go down, or stay the same. I'll just say S for stay the same. So there are 3 different ways that stock can perform. The first one, and so forth. There's 3 ways for each of these stocks to perform. They either go up, they go down, or they stay the same. So the number of combinations of this is 3 raised to the 9th power. Please do not put down 3 times 9. That is not the same thing. That number is 27. 3 to the 9th power is a large number. We're going to put this on our calculator. And the answer is 19,683. Question number 6. Evaluate the expression. Okay, so now we're going to use another formula. This is what we call permutations. So the permutation of 8 items taken 3 at a time. This we can use a formula of the permutation of n items taken r at a time, and that's equal to n factorial divided by n minus r factorial. And the n minus r is in parentheses. That's important here. Okay, so this is the formula. So we're going to evaluate this first by hand, and then we're going to put this on the calculator. So the permutation of 8 items taken 3 at a time is 8 factorial all over 8 minus 3 factorial, which is equal to 8 factorial divided by, now we're going to take what's inside the parentheses first, 5, and apply the factorial. And that's equal to 8 times 7 times 6 times 5. I'm going to stop right there because I know it matches what I have in the denominator. So if you don't have to expand it, there's no reason to, since it matches what's in the denominator, and I can cross that out now. All right, and if you want, you could expand it all the way out to 1, but that's not necessary here. And then we only need to put down 8 times 6, 7 times 6 in our calculator. All right, and that, so the total number permutations of 8 items taken 3 at a time is 336. Okay, now we have a calculator program. All right, so to use the program, we're going to the math key, and then we're going to arrow over to probability, and then we're going to press number 2, which gives you the NPR function. We're going to put 8 in for n, and then you use your arrow key, and then we're going to put the 3 in. Then hit enter and you get our answer, which is 336. Okay. So again, you go to math, prob, and you press number 2. You put in your numbers and then enter. Okay. And that'll give you your permutation function on the calculator. All right, the next number 7, use the formula for NPR to evaluate the following expression: the permutation of 16 items taken 0 at a time. Now, the formula will be pretty trivial because the number of ways of taking 16 items 0 at a time, there's only one way to do this. 16 factorial all over 16 minus 0 factorial, which is 16 factorial divided by 16 factorial, and we know any number divided by itself is 1. Okay, so we could punch that on the calculator, but I could save that for another problem. Problem number 8. For a segment of a radio show, a disc jockey can play 10 records. If there are 14 records to select from, how many ways can the program for the segment be arranged? Okay, now in this problem, number 8, this is an arrangement. Okay, that's a key word here, which tells you whether or not the order matters. Okay, if we're going to arrange things like books on a shelf or which order that the record plays in, the order matters here. Okay, so if the order matters, we're going to use a permutation. Okay, if the order does not matter, this would be a combination problem, and we would have to use a different formula. So this is indeed an arrangement where order matters. So we're going to use our permutation formula for n items taken r at a time, where in this problem, n is the total number of records that they can choose from, which is 14, and r is the number of records that they're going to play, which is 10. So we just put this in our formula, the permutation of 14 items taken 10 at a time. So really quick, let's do the formula by hand. And we get 14 factorial all over 4 factorial. Now this is quite a long expansion here. And it's not just because I'm running out of room, but you know, we do have a way of doing this on our calculator. We can put in this 14 factorial right here on our TI-83 or 84. So I'm going to clear the screen. We have 14. To get the factorial, hit math, prob, and the number 4. Okay, and then we're going to divide by 4. We're going to do this again. Press math, prob, 4. Hit enter, and the answer is, again, this pretty large number, 363,242,8800. So there's a lot of different arrangements that this disc jockey can put these records in a particular order. So the next number, 9, how many distinct ways can the letters of the word statics be arranged? Okay, this is a permutation again. And the permutation of any 6 letters, or let's see, 1, 2, 3, 4, 5, 6, that looks like 7 letters. Okay, if there were no repeats, so if there are no repeats in the letters, the number of ways that you can arrange the letters in a word is n factorial. Okay, but with repeats, we need to divide by the repeats. So whatever the repeats are, we find out how many times they repeat and put a factorial next to it. And then if there's another letter that repeats, we see how many times that one repeats, and we put a factorial, and we keep going until we finish with the repeats. Okay, so in this problem, we have the word statics. So that's 7 letters. So N is equal to 7. Now let's look at the repeats. We have 2 T's and we have 2 S's. And I believe we've got all the repeats there. So using the formula, the answer is 7 factorial divided by 2 factorial times 2 factorial. And that's 7 factorial all over 2 times 1 times 2 times 1. All right, so I just wanted you to see what happens when I expand a really low number like this. You don't even have to worry about the ones. So the answer is 7 factorial all over 4, and that we can put in our calculator. You can put this whole thing in the calculator too, that's fine. All right, but I thought this would be a simpler number. So we're going to get our calculator. 7 factorial divided by 4, and the answer is 1,260. Okay, so that's how many ways that the letters of the word statics can be arranged. The next, number 10, determine whether the following problem involves a permutation or a combination. It's not necessary to solve the problem. A medical researcher needs 19 people to test the effectiveness of an experimental drug. If 45 people have volunteered for the test, how many ways can 19 people be selected? Asking us whether or not this is a permutation or combination and why. So anyway, the problem is a combination because order doesn't matter. Number 11. You volunteer to help drive children at a charity event to the zoo, but you can fit only 7 of the 20 children present in your van. How many different groups of 7 children can you drive? So the fact that we did the last problem is kind of preemptive to this one because this is really indeed coming up with a number now. So we have to find out, is this a permutation or a combination? All right, so if we're going to pick up 7 kids out of the 20, put them in a van, the order in which they come in doesn't matter unless you're my kids and they call shotgun and they have to have a front seat. The order in which they come into van does not matter. So we're going to use our formula for combination. So this is the combination. Let's just go straight to our calculator now for this one. So this is the combination of 20 items. Hit math, prob, and now we're going to scroll down to number 3. And then we're going to put in 7 because R is 7. Hit enter, and the total number of ways is 77,520. Problem 12. How many ways can a committee of 3 men and 2 women be formed from a group of 12 men and 7 women? All right, now we have to decide, is this a permutation or combination? And we have 2 different groups to choose from. So let's first talk about whether or not, what kind of number problem this is. Now it did say committee, so that's kind of a clue. All right, since it's a committee, we know that we're working with a combination. So let's first see how many ways we can choose the men. So we need a committee of 3 men formed from 12. So N is 12 and R is 3. And for the women, the number of women to choose from is, let's see, it says 7 women, and we're choosing 2 at a time. And just remember that N is always the larger number, R is the smaller number. So the number of ways to choose the men is 12 taken 3 at a time. The number of ways to choose the women is 7 taken 2 at a time. You multiply those and then you get your answer. We can go straight to our calculator. So we have 12, math, prob, number 3, and then we're going to type in 3. And I'm going to get my answer. So this is 220. And then we're going to get the number of ways to get the 7 women 2 at a time, which is 7 math, prob, NCR, which is number 3. We put the 2 down, hit enter, and we have 21. Multiply those numbers. And so the total number of ways to choose 3 men from 12 and 2 women from 7 is 4,620. All right, number 13, a Senate in a certain state is comprised of 59 Republicans, 39 Democrats, and 2 independents. How many committees can be formed if each committee must have 3 Republicans and 2 Democrats? This is just like the last problem, so I won't be working it out completely, but we can set it up together. So we're looking for a committee with 3 Republicans and 2 Democrats. So let's see how many ways we can choose the Republicans. All right, now they say the number of Republicans we have is 59, and the number of Republicans we want on the committee is 3. Now for the Democrats, the number of Democrats is 39, and we are going to choose 2 for the committee. So since it's a committee, it's a combination 59 taken 3 at a time times combination 39 taken 2 at a time. And then you just put this on your calculator. You can also use a formula, right? Okay, number 14. A 12-sided die is rolled. The set of equally likely outcomes is 1 through 12. Find the probability of rolling a 6. Right now, there's only 1 6 in this entire group, so the probability of rolling a 6 is 1 out of a total of 12. Number 15, you're dealt a card from a standard 52 card deck. Find the probability of being dealt a 7. So just to get familiar with the deck of cards, we have 4 suits: clubs, diamonds, hearts, and spades. There are 13 cards in each suit, ace through 10, jack, queen, and king. Okay, so we have 10 plus 3 here, so there's 13 cards in each suit. So we have 4 suits, so 13 times 4 is 52 total cards in a deck. And each card, there are 4 ways of getting an ace, 4 ways of getting any number card. Okay, so 4 2s, 4 3s, 4 jacks, queens, kings, right? Half the deck is red, half the deck is black. So 26 are red, 26 are black. So the probability of being dealt a 7. Now we do know that there are 1, 2, 3, 4 7s out of this whole deck, which is 52. So the probability is 4 over 52. So we're going to put that on our calculator. 4 divided by 52. We want this in reduced terms, lowest terms. So we're going to hit fraction. So math, enter, enter. So 4 over 52 reduces to 1 over 13. You are dealt 1 card from a standard 52 card deck. Find the probability of being dealt a picture card. Okay, so let's look at our deck of cards here. we have 3 picture cards, which we also call face cards in each suit. So 3 times 4, so there's 12 picture cards. So the probability of getting a picture card is 12 over 52. Reduce it by pressing math, enter, enter. We get 9 over 13. Or no, sorry, I couldn't read that right. It's 3 over 13. Number 17. You are dealt 1 card from a standard 52 card deck. Find the probability of being dealt a diamond and a heart. Okay. Now, the setup is the fact that you are being dealt 1 card. What is the probability of getting both a diamond and a heart? There are no cards that are both diamond and hearts. Okay, so this is impossible. Therefore, the probability is 0 over 52, which is 0. That's a trivial problem. All right, number 18. The table shows the distribution by age and gender of the 29.9 million people in a certain region who lives alone. Use the data in the table to find the probability that a randomly selected person in the region is a woman in 18 to 24 age range living alone. So let's take a look. Now, probability always deals with the number of successes divided by the number of total possible outcomes. Okay. So in our table, we really need to know what our total is. Okay. Because probability always involves our totals. Okay. So our total, which goes in the denominator, is this 29.9, and that's in millions. The probability that a person is a woman that is 18 to 24. So I'm looking in the second row and first column, and that is 0.7. So 0.7 over 29.9. Now they want this as a decimal rounded to the nearest hundredth. So it's 0.02. Number 19. This table shows the number expressed in millions of citizens who moved in 2004. Find the probability of randomly selecting a citizen who moved in 2004 and who was an owner. So here are the owners, right? And the probability that a person that moved was an owner. Okay, now we need to get our total, and I don't see the total here in our table whatsoever. Okay, so let's go ahead and get the totals. Oh, and you know what? I think what I'll do is annotate my screen. So what we'll do is expand our table to get the totals. Okay, now they're totals of the rows. There's also totals here in the columns, right? So you just have to expand it according to what's needed in the problem. Right now, we really need to know what the grand total is here. So let's find out how many owners we have first. Okay, so the number of owners is 11.6 plus 2.7 plus 0.3, which is 14.6. And the number of renters is 18.8 plus 4.4 plus 1.0. We really need to know how many there is so we could get our total. All right, so I'm going to put that on our calculator. So 18.8 plus 4.4 plus 1 is equal to 24.2. And now we go ahead and add those two numbers. 24.2 plus 14.6, and the grand total is 38.8. We could have gotten this grand total if we summed up all of the columns as well. All right, so, which you're welcome to do. But it's not necessary in this problem because all we need is the probability that a person who moved in 2004 was an owner. So the total number of owners that moved was 14.6. So the probability is 14.6 divided by our total, which is 38.8. We're going to express this to the nearest hundred, which is 0.38. All right, the next problem is 20. 6 stand-up comics, A, B, C, D, E, and F, are to perform in a single evening at a comedy club. The order of the performance is determined by random selection. Find the probability that comic C will perform second. So how many ways can all 6 comics perform? All right, so this is going to be our total, because the probability formula of an event is the number of ways of getting that event that's favored over the number of ways to get your total sample space. And so let's get this denominator first. All right, so the total number of ways all 6 comics can perform. Okay, let's so what I'm going to do is put down all the ways that the first person can come to stage. We have 6 comics to choose from to perform first. Once one of them has performed, we now have 5 comics left to choose from. All right, so I am breaking each of these 6 acts down into these tasks, okay? And then once a comic has performed, we have 4 left to choose from, then 3, then 2, then 1, and we always end up with 1 for the last one to perform. So the total number of ways that 6 can go on stage is 6 factorial, which we can put on our calculator. That's 6 times 5 times 4 times 3 times 2 times 1. That is 720. I'll go ahead and put that on our calculator. 6 math prob 4 enter. We get 720. Okay, so we found out what the denominator was. Now let's get the numerator. The number of ways that comic C performs first. Okay, so, or what is that? Perform second, all right? So here we have 6 different people coming to the stage again, right? 1, 2, 3, 4, 5, 6. Now comic C is going to go right here in the second spot, and there's only 1 comic to choose from because we want C to go there, okay? And a lot of comedy clubs do this. They put their favorite comic or one that has maybe a time constraint, and they put them in order, and then the rest just are randomly chosen, go in the rest of the acts. So once one of the 6 is already chosen, we have 5 left to choose from to go first, 4 left to choose from to go third, then 3, then 2, then 1. Okay, so the total number of ways that comic C can go second, let's go put this on our calculator, is 5 times 1 times 4 times 3 times 2 times 1. And that's 120. It's also 5 factorial, by the way, right? So we have 120 divided by 720. And that reduces, well, that's a decimal 0.16 repeating. If we want to write it as a fraction, we press math, enter, enter, and that reduces to 1/6. In part B, we want to know how many, or find the probability that comic A will perform third and comic D will perform first. So we only need to know what the numerator is in our probability. So we have 6 events, or 6 acts, right? So first, second, third, fourth, fifth, and sixth. And they're telling us that comic A goes third and comic D goes first. So there's only one person to choose from there and here. And once 2 have already been placed, we have 4 comics left to go second. And then we have 3 to choose from who can go fourth, then 2, then 1. So the total number of ways this can happen is 4 factorial, which is 24. You could put that on your calculator. And so the probability is where if for in part B is equal to 24 divided by the total, which we already did here, the 6 factorial, that's equal to 720. And then we just simplify that on our calculator. And so that simplifies to 1/30. So part C, the comedians will perform in the following order: C, A, D, F, E, B. Okay. So there's really only one way that can happen. So intuitively, we might understand that the probability is equal to 1/720, okay? The reason is because the numerator, so you have your 6 different events, and C goes first, A goes second. There's only one person to choose from when you put them in this particular order, right? Only one person who can go in each of these events. So when you multiply, you get 1. So that's the numerator. And the denominator will always be the total ways, which is 6 factorial, or 720. And then finally, how many, or what is the probability that comic E or comic B will perform fifth? Okay, so we have our 6 different acts. We have first, second, third, fourth, fifth, sixth. Okay, now it says E or B can go here. So there's 2 to choose from. Once one of them has gone, we have 5 left to choose from who can go first. Okay, so we did have 2 people to choose from to go fifth. Okay, and again, once one of them has gone, we have 5 left, then 4, 3, 2, 1. If you do not end up with 1, then we have to go back and see what we did wrong. So the total number in our numerator, we can put this on our calculator, 5 times 4 times 3 times 2 times 2 is equal to 240. And we're going to divide that by 720. Press math, enter, enter, and the answer is 1/3. Okay, so number 21. A city council consists of 6 Democrats and 8 Republicans. If a committee of 7 people selected, find the probability of selecting 5 Democrats and 2 Republicans. I think we've already covered a problem just like this, so I'm going to move on to the next problem. Number 22. A hand consists of 4 cards from a well-shuffled deck of cards. Find the total number of possible 4-card poker hands. Okay. All right, so here for part A, the number of 4-card poker hands. All right, so that's a combination of 52 cards taken 4 at a time. All right, so we could put that on our calculator. We go to 52, then math, prob, NCR, which is number 3, hit enter. Oh, I didn't, let me go back up there. I pressed enter too quickly here. So we're going to put 4 for R and then hit enter. And that number is 270725. Okay, in part B, a red flush is a 4-card hand consisting of all red cards. Find the number of possible red flushes. So, all right, they say 4-card hand consisting of all red cards. So when we look at our deck, we know we have half of it, or 26 cards, are red. So this is a combination of 26 taken 4 at a time. And that answer is 14950. In part C, find the probability of being dealt a flush. So the probability of being dealt a flush consisting of, that's 4, a red flush is what, 4 cards consisting of all red cards. So we already found the probability, I'm sorry, the number of ways that that can happen. The probability is B over A, or 14950 all over 270725. And we just punch that out on our calculator. Sorry, my dog, I think, wants to go out, so I'm going to pause my meeting for a minute. Get 46 over 833. So that's the probability. So we're combining number methods with probability in these problems.